So for this video, I will be covering problem 5 in discussion worksheet 19. Next, it says consider the following molecules. What is the hybridization of the central atom for each molecule? Before I get to that, I want to let you know again that this table is on page 180 of your textbook, and it can be really useful for these types of problems. So first, we have sulfur dichloride. The central atom is sulfur, and you have 20 valence electrons. So when you draw it out, you should see that you have pairs around that sulfur atom. And that requires a tetrahedral arrangement to minimize repulsions. So this requires sp3 hybridized orbitals, 4 sp3 hybridized orbitals around that atom. So the central atom is sp3 hybridized. Next, you have silicon tetrachloride. The central atom is silicon. You have 32 valence electrons. So when you draw this out, this also has 4 electron pairs in a tetrahedral arrangement. So this is sp3 hybridized. Next, you have xenon tetrachloride. The central atom is xenon. You have 36 valence electrons. So when you draw this out, you should see that you have 6 electron pairs in an octahedral arrangement. This requires sp3d2 hybridization around that central atom. Last, you have krypton dichloride. Central atom is krypton. You have 22 valence electrons. And I gave an answer, but I'm going to have to draw this out. So you have krypton. So you have 5 electron pairs around that central atom. So it's going to be in a trigonal bipyramidal arrangement, and this requires sp3d hybridization. So this is the same slide as the first slide, but it has their answers for each of the following molecules. And one last thing I want to address is when you input these answers into line kappa, make sure that all the letters are lowercase, because even if you have the right hybridization, it'll mark it wrong. So make sure they're all lowercase.